This is a really cool and interesting problem. This rectangle is 1 unit high, and it's 1 unit plus, what's this width going to be? Well, it's a half plus a fourth plus an eighth plus a 16th plus a 32nd. So we showed in class that that infinite series converges to 1. So we can do this forever, but they get so skinny that as the number of times we have a new column approaches infinity, this over a rectangle is approaching 1 plus exactly 1. So the rectangle is 1 by 2. The rectangle's area is 2 because that's a 1 by 2 rectangle. Alright, so we're trying to prove that the sum of 1 over n squared as n approaches infinity is smaller than 2, which we're saying is smaller than the area of the rectangle because we know that's 2. Well, if we start with 1 squared, when n is 1, this is 1 over 1 squared, or 1. And then we go to n equals 2. So we have 1 over 2 squared, and then 1 over 3 squared. Well, we know that a ninth is smaller than a fourth. So if we move a half over and do a 1/2 by 1/2 square, 1/3 by 1/3 will definitely be smaller than the top purple square that was 1/2 by 1/2. And then for 1/4, well, that comes after 1/3, right? So let's make a square that's 1 over 4 squared. Well, we know that when n is 5, 1 over 5 squared is smaller than 1 over 4 squared. 1 over 6 squared is smaller than 1 over 5 squared. 1 over 7 squared. And we stop here because the next width is 1/8. So we go all the way up to when n was 7, and then when n is 8, we have 1 over 8 squared. And we can continue this pattern, and every subset of sums of 1 over n squared is not filling up all the space above this overall rectangle whose width is a half. So 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared and 5 squared and 6 squared and 7 squared, and then 1 over 8 squared, 9 squared, all the way to 1 over 15 squared. There's always less than this brown space that's not used. And we can represent this infinite sum as the colorful squares all added up for infinity, and it's necessarily smaller than the whole rectangle because of the space that's not getting filled in.